Okay. Good evening, students. Today, let us solve this question. Ideal gas whose CV is 5 to R is expanded adiabatically against a constant pressure of 1 atm until it doubles the volume. If the initial temperature and pressure is 298 Kelvin and 5 atmosphere respectively, the final temperature is what? In Kelvin. Okay, so CV is the molar heat capacity at constant volume, right? So here, what have we given? First, let's understand this question. Here, they've given us a right. So here, they have given us an ideal gas. Okay, there is a container. In the container, there is an ideal gas, right? And whose CV is given as 5 by 2 R. And it undergoes expansion. So this ideal gas undergoes expansion and its volume becomes double, right? So if this volume is V1, it is 2V1, okay? And it undergoes what expansion? Adiabatic expansion, right? So this is an adiabatic expansion, right? So what are the other things that we know? Temperature, initial temperature is 298 Kelvin, okay? And the initial pressure is 5 atm, okay? So what are they asking? They're asking the final temperature, okay? And so now let us solve the question, right? So okay. We know that by the first law of thermodynamics, delta U is equal to Q plus W, right? And if since it is adiabatic expansion, Q will be 0, so delta U is equal to W. Okay? So we can say that NCV delta T is equal to minus of P external V2 minus V1, right? And we also know that volume V2 is nothing but 2 times of V1 given in the question. Okay. And by the ideal gas equation, volume is nothing but nR T by T. Okay. So this is what we know. Okay. So if we solve further, we can say that nR T2 by T2 is equal to 2 times nR T1 by T1. Okay. So let's just cancel it out. We cancel nR on both sides. It will be T2 by P2 is equal to P2 by P2 is equal to 2 times P1 by P1, right? Okay. And we know that the initial pressure is 5 and the initial temperature is 29. Okay. If you just substitute it, you're getting P2 is nothing but P1, P2 on to P1. Okay. That is equal to 5 into P2 divided by 2 into 290. Okay. So this is going to be your P2. We're going to use this. We're going to substitute this. Okay. And let us bring back this equation. We can say that n 5 by 2 r T2 minus T1 is equal to minus of external pressure is 1. What is V2? V2 was nothing but we can say that nr T2 by T2 minus nr T1 by T1. Okay. So if we solve further, so T1 is nothing but what? 298, and we know that T2 is 5 T2 by 2 into 290. Okay. We're going to substitute this. So we'll be getting in 5R by 2, T2 minus 298, okay, equal to minus 1. Take NR now, is R T2 upon T2 minus 1 upon T1. Okay. So NR get cancelled. We'll be getting minus 5 by 2, T2 minus 298. Okay. Equal to minus of T2 T1 minus T1 T2 0 divided by P1, P2. Okay. So that is equal to P2. So that is equal to what? 5 into P2 minus P1 is 298 into 5 P2 minus 298 into, so P2 is nothing but 5 P2 upon 2 into 298. Okay, divided by 5 into 5 into 0.2 into 298. Okay, so we just cancel this out. So finally, we'll be on solving it. We get 3 by 2, P2 minus 298 is equal to 59.6. Okay, so therefore, P2 is nothing but 274.16. So approximately P2 is 374. Okay. So the final answer for this question is 374. I hope you understood this question, students. Thank you.